So as in previous video we have discussed about this oxidation, beta oxidation. Now we'll discuss about the energetics, that why we have done this process to gain energy. Fats are for gaining energy simply. So how we'll see how much energy we have gained from it. Firstly, I have told you that there will be, if we are taking the example of palmitic acid, that is 16 carbon, then 7 cycles will be there. Okay, so now see, here is FADH2 is forming. FADH2 is equivalent to how many? 1.5 ATP equivalent. Okay, here NADH is forming. This is equivalent to 2.5 ATP according to new classification. If you have any older version of any book, then there will be written 2 ATP and 3 ATP over here. So this is the newer form, latest version. Okay, 1.5 ATP and 2.5 ATP. Now this cycle is repeating 7 times. So that means 7 FADH2 will be formed. So if we talk about 7 FADH2 and 7 NADH will be formed. Okay. Now, one more thing I want to tell you, that this acetyl coenzyme which is formed, this acetyl coenzyme, where it will go? This acetyl coenzyme A will go to the TCA cycle, Krebs cycle. You know, na, acetyl coenzyme A is it will react with oxaloacetate acid and it will convert into citrate. Then the cycle continues. So this is a product. This will be continued in the TCA cycle, and Krebs cycle is also for energy. If you have learned the TCA cycle, then you will be knowing that in TCA cycle you get 10 ATP in each Krebs cycle. Okay, so we were discussing, and now this TCA cycle, this is how many times TCA cycle will be there? 8 times. Why 8 times? How many acetyl coenzyme A will be formed? How many acetyl coenzyme A will be formed? There was 16 carbon. Okay, 8 carbon. Obviously, that if we are getting rid of the carbon units by acetyl formation, acetyl is 2 carbon. So obviously 8 acetyl coenzyme A will be formed to finish the 16 carbon. So obviously 8 times 8. If 8 acetyl coenzyme A will be formed, then TCA will be repeated 8 times. So now 8 into 10, that is 80 ATP from the TCA. Okay, now this 7 FADH2. Okay, FADH2 we have discussed how many? We have using 1.5. It is 100, 10.5, 100. And this 7 NADH, 7 into NADH how many? 2.5, and it will form 17.5. Okay, if we add the 17.5, 10.5 and 80, we will get 108 ATP. But this is not the net ATP we are getting from palmitic acid, because as I have discussed in this, here this activation of fatty acids, we have used this ATP. But I have told you that we will consider 2 ATP because for pyrophosphate, 2 pyrophosphates are used and AMP is formed. Okay, not like 1 ATP is used and ADP, and this is not happening. This is happening, that 2 phosphates are used. So we will consider 2 ATP because we are basically calculating the phosphate amount. Okay, so here 2 ATP are used. Just 2 ATP are used in the lipid this breakdown oxidation. 106 ATP. This is the 106 ATP is the net yield for one molecule of palmitate. Okay, this is the net yield. So much amount of energy we are getting. Now if we discuss this 16 carbon, 16 carbon, if it is 14 or 12, 24, like this only will happen. Okay, but if there is any odd chain fatty acid, what will happen to it? If suppose it is an odd chain fatty acid, 2,2, we are getting rid of the carbon 2,2, like acetyl coenzyme A is forming. So in the end, suppose this is a chain, I'm just giving you an example, and this is 1, 2, 3, 4, 5, 6, this is coenzyme A. Okay, this is an odd chain. Now here what will happen, this 2 carbon will be separated, then again here coenzyme A will be there, will be put and this 2 carbon will be lost here again. So at the last you see 3 carbons are lost. If we here again form 2 carbon, then 1 carbon will be of no use, so we leave 3 carbons. You know now this coenzyme, like how this is forming. Every time this there will be coenzyme A putting in double bond over here, and acetyl coenzyme A will be formed every time, as we have discussed in beta oxidation in previous video. Okay, but in the odd chain what happened? The 3 carbon are left at the end. So there are two products. One is the acid at the end of the reaction, acetyl coenzyme A, and one is 3 carbon unit is known as propionyl coenzyme A. This is a 3 carbon unit. There are 3 carbon unit, propionyl coenzyme A. Now this propionyl coenzyme A will be converted in by an enzyme. Propionyl will be converted, I am telling you, D form of methyl. So here propionyl will be converting into D-methyl malonyl coenzyme A. Okay, this malonyl is a 4 carbon compound. So what will happen? You have to add carbon dioxide obviously, because it's 3 and it's 4 carbon. So which enzyme you will be using? This is propionyl coenzyme A carboxylase. Simple. Okay, carboxylase will be used. Now then D form is formed, but we know in our body L form is the active form. So we'll convert through race maze, you know, chemistry. This again chemistry is happening. Biochemistry. Chemistry will come. Okay, so D form will be converting into L form. Okay, methyl malonyl coenzyme A. Then what will happen? You will have to give a mutation. This malonyl have to convert into succinyl coenzyme A. And you know succinyl coenzyme A is a intermediate of TCA cycle. So it will go into TCA cycle, and again it will form the ETC cycle. Krebs cycle will be repeated, and you will get 10 ATP. What I was saying is when there was even chain, then acetyl coenzyme A was produced. This also has to go to the ETC, and here succinyl coenzyme A is formed, so it has to also go to the TCA cycle. So is there any difference? Yes, because here when this propionyl is formed, ATP is consumed and it will form ADP plus phosphate. 1 ATP here is consumed every time, so you have to reduce that amount also. Okay, and here to convert into succinyl coenzyme A, this mutase will use vitamin B12. So in the deficiency of vitamin B12, you cannot convert this odd chain fatty acids this coenzyme A into fatty acids, obviously into succinyl coenzyme A. Okay, so here you need ATP. Remember that. So this was about odd chain and energetics. Now next part I'll do in next video. Thank you.